Good morning, guys. Today is the first audio-visual lecture of concrete technology. We are doing the audio-visual lecture with the help of Bandicam software. Why we are doing audio-visual? That we know that today is the most important topic of concrete technology that we will discuss. Why? Because in the concrete technology, the most important topic is the mixed design of a concrete. Okay, we need to find out what are the proportions that are needed for a concrete so that the concrete mix becomes having certain minimum strength and durability. So to know that, first let us understand something. Till now we have discussed various properties of cement, various types of cement, various properties of aggregate, various types of aggregate. Okay, then we have discussed the effect of aggregate on the strength of concrete. Then we discussed the various type of concrete. What are the properties of concrete? Strength, durability. All this leads to the mixed design of concrete. Why we have discussed all this? Because at the end we have to design a proper mix for the concrete. Now, what is a proper mix? Consider you are working in a site. Okay, consider you are making a two-story building where there are two number of stories, ground floor and first floor. And in another site you are making 100-story building. So there has to be some difference between these two buildings. The concrete that will be used in that building and the concrete has to be used in that building. There has to be some difference between that. Now, that's why we need the mixed design. So the grade, the compressive strength for that concrete to be used in the two-story building and the concrete that will be used in the 100-story building, the 100-story building concrete will have much more higher strength, much more higher property, much more higher material involved. Okay, so that's why there is a need of mixed design. Consider a concrete of M25 that we know what is the M. M is the mixed proportion M25. In M25 the proportion of the M25 is what the proportion of the M25, that is equals to 1:1:2. That is a mixed proportion of the concrete. Okay, for the M25 concrete. So for M25 concrete, if it is the mixed proportion, that means what is meaning of 1? 1 means the cement, proper weight of cement, 1 means the weight of fine aggregate, and 2 means the weight of coarse aggregate. So if we are selecting these three proportions, that means there are some qualities of the cement, the fine aggregate, the coarse aggregate we are using. So consider we are not getting that standard value of the coarse, fine or cement standard quality. So for that we are getting some different quality. So if we are considering that the different quality, so that mixed up proportion that we are using here will also be different. So for this different type of proportion we need to design the mix. So there comes the requirement of the mixed design. So what is the mixed design? It has been specified there as it is a process of selecting suitable ingredients of concrete and determining their relative properties with the objective of producing of concrete of certain minimum strength and durability. That means consider we are making M25 concrete. So first we need to determine which material to be used, what are the material available to us, what are the qualities of the material that we are using, and then we need to design the mix. We need to calculate the various proportions of that materials so that we can get the minimum stipulated strength and durability. For M25 concrete, the minimum strength to be achieved is M25. So we need to make it sure that the concrete, after making the concrete, if we test it in the compression testing machine, it should give a strength higher than at least 25. So this is the motto of our mixed design. So these are the two objectives of the mixed design. First objective is to achieve the stipulated minimum strength and durability that I have discussed for M25 concrete. Minimum M25, that is a 25 Newton per millimeter square or 25 MPa that we need to achieve. And the second one is to make the concrete economical. Consider why is the second point important, very much important to make the concrete economical. Some of you may also say that, sir, we are making a concrete M25, so let us make a concrete M40. So M40 is much more higher strength than the M25, so the strength and durability criteria is getting fulfilled. But to make the M40 concrete, the material that are required are very much high and very much more than the actual required. So we need also to be concerned about the required amount of material. That means we need to keep the material as far as the limit. For that we need to design the concrete mix. So our mix design of the concrete is the most important part of the concrete. Okay, so now, mix design of concrete provides a sophisticated approach and guidelines for proportioning of the concrete mix as per the requirement of the concrete making the materials and other supplementary materials. Okay, that you all know. Now, to achieve specified characteristic as specified age. Now coming to the mixed design codes. Various countries have their various codes for mixed design. Consider for United States, for UK, for Europe, for America, for Australia, there are various codes of mixed design. They follow their own codes. But as we are in India, we need to follow our code. This code of mixed design is IS 10262 2019. Now, before the previous syllabus, as per the previous syllabus, the IS code was IS 10262 2009. This was the previous code, but the code has been heavily modified and now we are going for the IS 10262 2019. Okay, we are going for now that code. So we will be designing the code for that. What is the basic difference between two code? In the IS 10262 2009, various parameters were not given. Parameters like air content, use of air content in the concrete was not given. The criteria for high strength concrete design was also not given, and the criteria for the self compacted concrete was also not given. So for that, the IS 10262 2019 uses all these parameters. Okay, uses all these parameters. Now coming to the mixed design as per IS 10262 2019. Okay, now at first there are some data required so that we can do the mixed design as per the IS 10262 2009. So first let us open the IS 10262 2019. Okay, this is the code of IS 10262 2019. You can see here it is specified that IS 10262 2019. So first we will discuss what are the basic data that we require for the mixed design. So for the mixed design, we need the various properties of the material that we will be using for cement, for aggregate, for water, for mineral admixture, for chemical admixture, etc. We need all the data for the mixed design. So first we need to come to the what are the data are required as per IS 10262 2019. It will be 19. Okay, 19 clause number 4. Clause number 4. So this is the clause number 4, data for mixed proportioning. So as per IS 10262 2019, the data that are required for clause number 4, the data that are required are they are the various data. Grade designation. What is the meaning of number A? Is the grade designation. That means which concrete we are producing. What is the grade of the concrete? Are we producing M35? Are we producing M40, M25, M20? Which is the grade? What is the grade? That is the M value. M40 or M25, anything we need to what is the grade designation. Second is the type of cement and the grade of cement. Type of cement means which type of cement you are using. Consider it may be Portland slag cement, it may be Portland Pozzolana cement, or it may be normal OPC, ordinary Portland cement. So for that there are some type of cement and the grade of cement. What are the grade? That means what is the compressive strength of the cement. For OPC 33 grade, we know the compressive strength is 33 Newton per millimeter square. Similarly for OPC 43 grade, we know the strength is 43 Newton per millimeter square, and for 53 grade the strength is 53 Newton per millimeter square. So the grade of the cement, maximum nominal size of the aggregate. So the coarse aggregate we are using. So what is the maximum size of the aggregate? Is it 20 mm? Is it 10 mm? Is it 40 mm? What is the maximum nominal size of the aggregate? Then the minimum cement content out of cementitious material content and water cement or water cementitious material ratio to be adopted. That means what is the minimum cement content we can provide as per IS 456. I will discuss it later on, that as per the IS 456 2000, the minimum cement content is also specified. That means the minimum cement content means that much cement content we have to use. Okay, so for a concrete the minimum cement content is specified. Similarly, the maximum water cement ratio also specified depending on the grade of the concrete. If M40, M35, for that the maximum water cement ratio that we can provide is also given. So the minimum cement content and the maximum water cement ratio is another thing we need. Also, or the exposure condition. Exposure condition means in the water cement ratio lecture that I have discussed in your class, I have shown you as per IS 456 table number 5, the exposure conditions are given like mild, moderate, severe, very severe, and extreme. These are the exposure condition that the concrete is supposed to be. So these are also the data we require. Then comes the workability required at the time of the placement. So workability, you very much well know what is workability. That means the ease of working. So the workability of the concrete that you are using. What are the tests? They are generally done for the workability that you may know. That is, I think you have studied that slump test, compacting factor test, VB consistometer. So the workability requirement. Now, as per IS 10262 2019, the workability value, the workability test as per the IS 10262 2019 is the, as per IS 10262 2019, the workability test that this code follow is the slump test only. So the slump value for this test that we will be requiring. Next comes the transportation time. So how much time it requires to transport the concrete from one place to another. Then comes the transportation time. Then comes the method of placing. If the concrete is placed normally or with the help of any other thing, we will come in when we are designing the thing. There are some type of concrete where the concrete is need to be placed with some type of equipment like hydraulic pump. For hydraulic pumping, there are some extra criteria that will be added. So type of placing, method of placing is also important. Then come the degree of the site control. Degree of the site control, good or fair. So what is the site control? So the quality control of the concrete. What is it? I have discussed it in the previous theory class that I have discussed with you in the online, that what is the quality control of concrete. So if the quality control is good or if the quality control is near about fair, so these two criteria we need to consider. Okay, so this is another criteria. Next comes the type of the coarse aggregate that we will be using. Coarse type means if it is angular, subangular, granular, gravel with crushed particle, rounded gravel, or manufactured coarse aggregate. These are the various types of coarse aggregate that this code considers. For each type of aggregate, the value will thereby adjust. So the type of the coarse aggregate is also important. Next comes the type of the fine aggregate. Natural sand, crushed stone or granulated sand, manufactured sand, mixed sand, etc. So the type of the fine aggregate is that much also important. Next comes the maximum cement content. So in the earlier stage I have discussed the minimum cement content. So as per the IS 456 also there is a maximum cement content. That means how much maximum we can use the cement. So the cement content has a limit, lower limit and upper limit. So the maximum cement content is that much important also. Next come the whether a chemical admixture shall or shall not be used, and the type of the chemical admixture and the extent of its use. Chemical admixture, that module I haven't taught you till now. It will be taught after the mix design. I have kept it because for to understand the chemical admixture, some higher amount of knowledge is required. So I will discuss it in the last module. As a last module, chemical admixture means sometimes to increase the property of the concrete. Okay, consider we are placing the concrete in a zone where they require a huge workability at a controlled strength. So to increase the workability at a higher limit, we need to apply some chemical into it. Okay, they are called the admixtures. Okay, the admixtures are very much important nowadays. Some of the admixture that as per this code they are specified as plasticizer and super plasticizer. Plasticizer and super plasticizer, they are the admixture that are specified by this code. So we will be using plasticizer or super plasticizer if it is specified. Then comes the whether a mineral admixture that are used. Mineral admixture is nothing but cementitious material is nothing but the mineral admixture is nothing but the cementitious material that we are using. In the cement chapter I have told you about what are the cementitious material that we are generally using, like fly ash, gram granulated blast furnace slag, GGBFS, gram granulated GGBFS, fly ash, silica fume, that to be used or not. If it is specified that it has to be used, for that mix design will also change. Next come the any other specific requirements like early edge strength requirement. Early edge strength requirement means if we are using rapid hardening Portland cement, for the rapid hardening Portland cement the strength will develop faster. So if there is a requirement early edge strength requirement, we need to use rapid hardening Portland cement. So as per the data required for mix designing, I have taken these data from here also only. These are the data that are written here. Okay, so I have taken the data. So these are the data we require for the mix design. So now we need to coordinate. From the starting of the concrete lab, we are doing the tests for the cement, aggregate, concrete, etc. For cement, we have done soundness test, setting time, consistency, fineness test of cement, specific gravity of cement. For coarse aggregate, we have determined the fineness modulus. By sieve analysis, we have determined the specific gravity of the coarse aggregate. Okay. In the concrete test, we haven't done till now. The tests that are in the concrete, like slump test, I think you have studied in the book what is slump test, like compacting factor test. So all these test result, all this leads to the mix design. So we will need all the data we have done in the lab. By requiring all the data, we will do the mix design in the lab. So all the tests that we have done till now and we will do in the concrete lab, all the tests leads to the final mix design. Okay, so the mix design is the final stage and the final frontier of concrete technology. So it is the most important thing. Now coming to the design procedure, that is the most important thing. What are the design procedure for the mix design? Now there are various numbers of steps that are involved and various checks that need to be done. For each and every steps, there may be number of checks we need to do. So we will need to follow all the steps throughout. I will discuss in my lecture that how we need to follow all the steps. Then we will discuss how the checks are applied. Then we will see in between some small examples that how that things are calculated, how the checks are applied. We will see through that. Now the first step 1 is the calculation of the target mean strength for the mix proportioning. As per clause number 4.2, target strength for the mix proportioning. This is the clause number 4.2 of IS 10262 2019. So coming to the target mean strength. What is target mean strength? Mean means average. The IS 10262 says that when we are making a concrete and then we are determining the strength, we need to determine the strength for some higher specific value. Why? So that if we make and batch various batches, consider 10 numbers of cubes for to check it for the compressive strength. We generally the check the strength compressive strength test for the concrete is done in the compressive testing machine, and we need to make a cube for concreting. So when we are doing the compressive testing in cubes for a certain gate, consider we are making M30 concrete, so consider we are making 20 numbers of cube. So why we are using some higher value of the strength? So that it has been specified in order not more than a specified proportion of the test results are likely to fall below the characteristic strength. That means, what is the characteristic strength? That is the 28 days strength of the concrete. For M40, what is the characteristic strength? 40 Newton per millimeter square. For M25, it is 25 Newton per millimeter square. So the characteristic strength, that means in order not more than a specified proportion, consider we are taking 5% of the result, below 5% of the result will fall. That means we are making 20 numbers of cubes, 20 numbers of cubes we are making. So 20 numbers, 5% of 20 numbers means 1 cube. So 5% of the 20 numbers means 1 cube result. 1 cube will fail in the compression testing machine, not more than that. So if we need to ensure that 5% of the cube result will below 5% of the cube result will fail. So we need to make the concrete, we need to make the strength, we need to take the strength at a higher level as per the IS code. It is said here, in order not more than a specified proportion of the test results are likely to fall below the characteristic strength, the concrete mix has to be proportion for a higher target mean compressive strength, which is called the target mean strength, FCK dash. I have written the formula here. So FCK dash is the target mean strength, that the higher value of the strength. FCK dash equals to, two formulas are there, as you can see, two formulas are there, FCK plus 1.65 into S, or FCK dash is equal to FCK plus X, where FCK is the characteristic compressive strength at 28 days curing. For M40 it is 40 Newton per millimeter square. For M25 it is 25 Newton per millimeter square. S is the standard deviation value as per table 2. Now coming to the standard deviation value. What is table 2? This is table 2. Assume standard deviation value. For M10, M15 it is 3.5, 20, 25, 4.0. For 30 to 60 it is 5.0, 65 to 80 it is 6.0. So this is the value of the standard deviation. So 1.65 into S, this is the standard deviation. And the second one is X. X is the factor based on the grade of the concrete as per table 1. It is just above table 2. Table 1 value of X. For M10, MT15 the value of 5, 20, 25 5.5, and for 30 to 60 it is 6.5, and 65 and above it is 8.0. So the value of the S and the value of the X to be taken from table number 1 and table number 2 to calculate the target mean strength of the concrete. So let us try one example, small example. Consider we need to determine the FCK dash for M45 concrete. So if it is M45 concrete, so what is the value of, so if M40 concrete, so what is the value of the characteristics compressive strength FCK? As per this test, FCK characteristics compressive strength 45 Newton per millimeter square for M45 concrete, 45 Newton per millimeter square. Now from table 2, consider we are getting from table 2. So from table 2 for M45 concrete, for table 2 for M45 concrete, what is the value of the S? That is M45, the value is 5.0. So we are putting F 5.0 and another FCK dash X. So X calculated from table number 1. So M45 that is equals to 6.5. So putting the value here 6.5. So FCK dash will be equals to 45. For getting the formulas, two values were coming, 53.5 and 51.5. So which value to take? As per the IS code, it is said here whichever is higher. So always whichever is higher we have to take. So always the higher value we have to take. So in this case, in this small example, we will take the higher value, that is the 53.5. so that's how the first step, that is the target mean strength, is calculated. So first step is calculation of the target mean strength. That's how it is calculated. Now, so what is the requirement of this target mean strength? This target mean strength, the concrete design, the mix design will be based on this target mean strength. So as we are designing the concrete mix for this target mean strength, the requirement of the concrete will automatically pass, because we are designing for some higher amount of mix. Clear? Next, there are some checks. So I have also previously told you that for each step there are some number of checks to be applied. Check number one is specified here. If we enlarge that a little bit, it is said that the above values correspond to a good degree of site control. That means for table 2, the standard deviation value is for the good degree of site control. Sometimes the degree of site control may not be good, it may be fair degree of site control. Okay, let us read from here. Site control having proper storage of cement while balancing all materials are same, regular checking. Okay, where there are deviation from the above, that means where there are these qualities are not meeting, so it should not be a good site control. It is termed as fair site control. That I have told you in the data required, that is the method of site, degree of site control, good or fair. So it may be good, it may be fair. For fair site control, the values given here to be increased by 1 Newton per millimeter square. That means we are considering M45 and the site control is fair. So 5 plus 1.0. So here the value will be 6. Very much important thing that we need to consider. Okay, this is check number 1 we need to follow. Clear? This is check number 1 for step number 1. So there will be number of steps and number of checks with each number of steps. So this is the first step and first check. First step, we have calculated the target mean strength. Now for the target mean strength, we will proceed with the design. Step number 2 now we are coming. Step number 2 says approximate air content determination. We have to determine how much air content is determined. So estimation of the air content, this is step number 2, determination of the estimated air content. Air content is required for a required amount of workability. As per IS 10262/2009, that a previous code, it was not there. It has been introduced here new. So we need to consider that approximate air content will be as per table number 3. This is table number 3. So as per table number 3, the approximate air content depends upon the nominal maximum size of the aggregate. So which is the nominal maximum size? It may be 20 mm, it may be 10 mm, it may be 40 mm. Okay, aggregate size used for the mixed design of concrete cannot be more than 40 mm. Okay, it cannot be more than 40 mm, because 40 mm is the highest value that we can use. So for each value, the values are given: 1.5%, 1.0 entrapped air as percentage of the volume of concrete. That means 1.5, that means the value given here, what does it represent? It represents for 1 meter cube volume of concrete, air content volume will be equal to 0.01 meter cube, that is 1% for 20 mm size of the aggregate. So if the aggregate size is 20 mm, if the aggregate size is 20 mm, for 20 mm 1%, that means for if the size of the concrete, volume of the concrete is 1 meter cube, as per it is given as the volume of concrete. So if the volume of concrete is 1 meter cube, so 1 into 0.1 into 1%, that means 0.01 meter cube will be the volume of the air void. We will need this volume when we are calculating the mixed proportions. So this volume is important. So this is in step 2. The step 2 does not have any checks. It is a normal step. We need to consider the air content. Now coming to step 3. Step 3 suggests that selection of the water cement ratio, clause 5.1 of IS 10262. Now coming to clause 5.1, selection of the water cement ratio. Now, this is the most important part, because in the strength criteria, when we have discussed in the class, I have told you that the water cement ratio is the most important part, and the strength is directly related with the water cement ratio. You know that. So the what is the water cement ratio that is required, we need to find out. Now, different cement, different aggregate, different type of coarse and fine aggregate, different admixtures used, all these controls the water cement ratio. Why? Because if we use different type of aggregate, different type of cement, different type of fine aggregate, different amount of mineral admixture, etc., so we will get various differential amount of different amount of water cement ratio for same amount of concrete. That means, consider for M40 concrete, we are determining if the aggregate is 20 mm size, we may get a value of water cement ratio X, and if the aggregate size is 40 mm, we may get a value of water cement ratio Y for the same value of the characteristics compressive strength. So the theory, the requirement, the need of the water cement ratio, the calculation of the water cement ratio is very much important. So we need to find out the water cement ratio. So in absence of any data, the trial water cement ratio to be selected from relationship in figure number 1. We need to determine the water cement ratio with respect to figure number 1. What is figure number 1? This is figure number 1. Okay, this is figure number 1. So in figure number 1, a chart is given. In the vertical axis, it says the 28 days compressive strength, that is the grade designation. For M40 it is M40, for M25 25, and the y-x axis is given the free water cement ratio, and three curves are there: curve 1, curve 2, and curve 3. So it is said that curve 1 for expected 28 days compressive strength, curve 2 for 28 days compressive strength, and curve 3 for expected 28 days compressive strength 53 Newton per millimeter square and above. That means curve 1 is for OPC 43 gauge. It has been said here curve 1, 2, and 3 may be used for OPC 33, OPC 43, and OPC 53. So for curve 1 we will take OPC 33 grade, curve 2 we will take OPC 43 grade, and curve 3 we will take the value of curve 3, that is OPC 53 grade. Now consider, we need to determine a value of M. We need to determine the water cement ratio required for M35 concrete. M35 concrete. So consider for M35 grade concrete we are determining. So for M35 grade concrete, what is the value of FCK dash? What is the value of FCK dash for M35 concrete? FCK dash for M35 concrete is 43.25 Newton per millimeter square. FCK dash. You can calculate the value. I have calculated the value, so I have put here 43.25. Now we have to determine the water cement ratio for that characteristic, so that target mean strength. So 43.25 will come in like if it is 45, it is the center, it will be like here. So 43.25, we will draw a straight line, and if consider we are doing it for OPC, we are doing it for OPC 43 gauge. So for 43 grade we will have to take curve number 2. So for curve number 2, if we draw a straight line, perpendicular line here, we draw a perpendicular line here. Wait a minute. Wait. So for 43 grade cement and 43.25 Newton per millimeter square target mean strength, the value we are getting is near about 0.35 and 0.4. Consider it is to be 0.36 7, the value we are getting for M35 concrete, and therefore 0.37 is the trial mix we need to determine. So that's how we determine the trial mix for the water cement ratio as per the IS code. So this is the procedure for determining the water cement ratio. Clear? Now coming to the check. Here is coming to the check number 2. Previous we have done check number 1 in step number 1. Now coming to check number 2. It is been said here, in absence of any data for cement PSC and PPC, IS 10262/2019 suggests a cement can be either PSC or PPC. Rapid hardening cement, sulfur resisting cement, this code do not use that code, that type of cement only. They have used either it is PPC, that is the Portland Pozzolana cement, and either it would be Portland slag cement. Okay, so in case of Portland Pozzolana cement and in case of Portland slag cement. So now coming to what is the extra material in Portland Pozzolana cement. In the Portland Pozzolana cement have a cementitious material called fly ash, and Portland slag cement has a cementitious material ground granulated blast furnace slag. So they have considered only these two type of cements. Now it has been said there, while using PPC and PSC, the appropriate curve as per the actual length may be utilized. In absence of any data, curve 2 can be taken. So consider we are taking PPC or PSC. So for PPC or PSC, that means Portland Pozzolana cement or Portland slag cement, the 28 days compressive strain to be taken for curve number 2 of figure 1. So this curve has to be taken for the required curve. If check number 2 for PPC and PSC, we have to take this curve as our required curve. So we need to determine the water cement ratio depending on this curve. This is check number 2. Next coming to check number 3 in step number 2. What is the step number 3? The trial value of the water cement ratio shall also be less than the maximum water cement ratio. The trial value of the water cement ratio shall also be less than the maximum water cement ratio as per clause number 5.1.2, where the water cementitious material ratio shall be calculated in accordance with table 5 of IS 456. Okay, and so we need to see what is in table 5 in IS 456. So let us open IS 456 table number 5. This is IS 456. So if we go to, this is IS 456, okay, 2000, IS 456 2000. So we are going for table number 5. Table number 5 is like, okay, so table number 5. The table number 5, it has been, I have also, for your better understanding, I have shown the table here also. The table is shown here also. This is table number 5. What the table says: minimum cement content, that would the data we require, maximum water cement ratio, and minimum grade of concrete for a different exposure condition for a nominal 20 mm size aggregate. That means if we have determined the water cement ratio, table number 1, from here we need to check it for the maximum water cement ratio depending on the condition. So for mild, moderate, severe, very severe and extreme condition, the value changes. Consider we are for mild condition. The maximum water cement ratio for plain cement, that is PCC, plain cement, that means P, C and C, and reinforced concrete means RCC. So there are two difference. So for means mild condition, the maximum water cement ratio is 0.6, and for RCC it is 0.55. For severe 0.5, for severe 0.5 and 0.45. So these are the maximum water cement ratio, and this is the maximum water cement ratio for RCC. So we need to check it. We need to check it as per the code if the maximum water cement ratio is satisfied or not. For example, I have shown you an example here. So for example, we get the target mean strength. For example, we are getting a target mean strength of 45 Newton per millimeter square. We are getting a trial value of 45 Newton per millimeter square. Type of cement is equal to OPC 53 grade. Exposure conditions severe, and for RCC concrete. So first we need to determine the required trial water cement ratio for figure number 1. So for 45 Newton per millimeter square FCK dash and type of cement OPC 53 grade. So coming to table number, again we are going for IS 10262. So here from 45, this is 45. So if we draw a straight line, OPC 53 means curve number 3. So for 53 we are getting a value near about 0.43. Near about 0.43 we are getting a value near about 0.43. So for 0.43 we are getting a value for M to FCK dash 45 and OPC 53 grade. Now this is the value we have taken as a trial mix. It should be less than, so as per check number 3, it should be less than the maximum water cement ratio. Now coming to the maximum water cement ratio, for severe condition, the maximum water cement ratio can be provided is 0.5 and 0.45 for RCC and for PCC. So here for RCC concrete, and severe condition, the maximum is 0.45. so we are putting the value 0.45. so 0.43 less than 0.45, hence it is satisfied, hence it is in the prescribed limit, it is not crossing the limit, so hence it is okay. So we have to check it by this procedure. So check number 2 and check number 3 we need to follow here. Okay, so this is coming to check number 3 and check number 2. Clear? Now coming to the step number 4. Step number 3 is the calculation of water cement ratio. Now coming to the selection of the water content. This is step number 4. Step number 4 is the selection of the water content and admixture content. What is the chemical admixture? How much chemical admixture we will use? We will determine that here. So it will be as per 5.3 clause. So this is selection of the water content and the admixture content. Now quality of the maximum mixing water, per unit volume of the concrete as given table 4 of IS 10262 2019. So coming to table 5, so water content per cubic meter of the concrete for nominal maximum size. So how much water, what is the weight, mass of the water, weight of the water that to be taken for 1 meter cube, for per meter cube of concrete, cubic meter of concrete, so per meter, so 1 meter cube of concrete, how much water, how much weight of water we require, we will get it from here. So it is dependent on the nominal maximum size of the aggregate. So for 10 mm the mass of the mass weight water content to be used for 1 meter cube is 208 kg per meter cube. It is the wind is kg, that is the mass. For 20 186, for 40 165. so the chart for your better understanding it is specified here also. So for 10 208 20 186 and 40 165, it is for that. Now it is been said here this value is as per the water content table 4, that is in the table 4 is for angular coarse aggregate only and for 50 mm slump value. So angular coarse aggregate and 50 mm slump value, that is the workability. Sometimes the coarse aggregate may not be that, the slump value may not be that. So for that we need to apply some checks. So coming to check number 4, that is the aggregate size. So aggregate size and aggregate shape, if it changes. So as per 5.3 it has been said that the water estimate in table number 4 can be reduced by approximately 10 kg for subangular aggregate, 15 kg for gravel with some crust particle and 20 kg for rounded gravel to produce the same workability. That means if we are using any other aggregate than the angular aggregate, we need to reduce the water content. Consider we are so it has been written here, I have also written here, for subangular aggregate reduce 10 kg, for gravel with some crust particle reduce 15 kg, for rounded gravel reduce 20 kg. So this is the first check we need to apply. Clear? So the value we have got, consider for 20 mm we are getting 186 kg per meter. So if we are using subangular aggregate, it will be 186 minus 10. Okay, 186 minus 10. For here it will be 186 minus 15, and similarly it will be minus 20 as per the code specified value. So this is the for any other type or size of aggregate. IS code 1026/2009 says only these three type of aggregate can also be used: subangular, gravel with crust particle, and rounded gravel. If it is specified, then we have to apply this check. If it is not, we do not need to apply. Coming to check number 5, slump value, that is the workability. As I have discussed earlier, the test for workability IS 1026 to consider is only the slump test. What is the slump value? I think you may have known what is the slump value. For better understanding, I am showing you. So the slump test procedure is there is a slump cone will be there. We need to place the concrete here. Then we need to put the slump in the upward direction. After pulling the slump in the upward direction, the concrete will take shape like that. So the difference of the top level of the concrete to that top level is called the slump value. This length is the slump value. Okay, no, so this value, this chart, this water content are for only 50 mm slump value. If the slump value is somewhat higher or lower, then we need to apply some other checks. So here it is side for other desired workability other than 50 mm slump value. Other than 50 mm slump value, it is been said here, other than 50 mm, the required water content may be increased or decreased by 3% for each increase or decrease of 25 mm slump value. That means for slump value other than 50 mm, for additional increase or decrease of the slump value from 50 mm, respectively increase or decrease the water content as per this formula. For each 25 mm increase in the slump value, 3% increase in the water content. For 25 mm decrease in the slump value, 3% decrease in the water content. Why we are increasing the water content with the increase in the slump value? Slump value increase, that means this height is getting higher. So if the height is getting higher, so for that we need to increase the water content. Okay, so we have to apply the checks here, and for if it is not 25 mm, it may be 18 or 17. For that, for an intermediate value of the slab, adjust the water content by respectively. So we have to apply interpolation for that case. If a math comes in the exam, I will show you in the next example. In the next lecture, we will do an example, an exercise. Here the slump value will be changed, so we will show that. Now for example, if the slump value is 50 mm, 100 mm, so this chart is only for 50 mm slump that has been specified, so it is 100 mm. So then the increase in the slump value is from 50 is 50 mm, 100 minus 50 is equal to 50. So for 50 mm slump, so for increase in the 25 mm slump value, increase in the water content 3%. Increase in the water content 3%. So here how much is increased? 50%. So for 25 mm increase 3%. For 50 mm increase will be 3 plus 3, 6%. Water will be increased. So actual water content, if maximum nominal size of the aggregate 20 mm, consider we are taking the nominal size 20 mm. So what is the water content specified here? 186. So here we have to increase the water content by 6%. So 186 plus 186 into 6%, that is 197.16 kg. This is the water's content that we will provide now, 197.16 kg. So the water content has increased, so we need to provide this adjusted water content. So this is check number 5, very important check. If the workability values are given in a slump value other than 50 mm, so we have to apply this check. Coming to check number 6, one of the most important checks in the mix design, check for chemical admixture. If we use the chemical admixture, that the code accept is only plasticizer and super plasticizer. What is the work of plasticizer and what is the work of super plasticizer? Plasticizer provide higher workability at same strength or same higher strength at same workability, and super plasticizer do the same thing but some higher value, higher than plasticizer value. So the workability will change. So if we are increasing the strength without decreasing the workability, that means we are lowering the water cement ratio, water content. So we are water content, if it is lower, then the water cement ratio will always be lower, because water by cement is the water cement ratio. If we are lowering the water cement ratio, so the water cement ratio will become lower, so the strength will increase, but the workability will, if the water content becoming lower and lower, the workability will also be lower. But super plasticizer or plasticizer do that work. In the lower water cement ratio, they provide higher strength but do not affect the workability. So as per the code specified, it is been said here that where it is, the water so calculated can be reduced by use of chemical admixture, water reducing admixture or plasticizer if you use, or super plasticizing admixture, usually decrease the water by 5 to 10% and 20 to 30% and above respectively at appropriate doses. That means if we used plasticizer and super plasticizer, high range water reducing admixture or high range water reducing admixture, the water content can be decreased by, as per the code, if plasticizer used, reduce water content 5 to 10%, which has been said here, and if super plasticizer used, 20 to 30% and above, specified by the code. So we are following all the codes. Okay, so we need to again decrease the water content if plasticizer or super plasticizer is used by this value, 5 to 10% and 20 to 30%, depending on the type of the chemical admixture that has been used. Either it will be plasticizer or it may be super plasticizer. Clear? So we have to again reduce the water cement ratio if the chemical admixture is specified in the math. Okay, now coming to how much will be the chemical, it has been said here as per the above respectively appropriate dose. So what is the general dose of the admixture, or general chemical admixture? Now the reduction depends on the chemical admixture as per the code. As been said, generally the dosage of the plasticizer or super plasticizer varies from 0.1 to 0.4%. Only plasticizer, not super plasticizer. And for super plasticizer, 0.1 to 0.4% of the total weight of the cementitious material. Total weight of the cement. What is cement and cementitious material? We are coming in the next step. We are determining the cement and cementitious material. And if it is super plasticizer, then use this 0.5 to 2.5% by the weight of cementitious material. So this is the doses, 0.1 to 0.4% by the weight of the cementitious material or the cement for plasticizer, and 0.5 to 2.5% for the weight of cement for super plasticizer used. And the specific gravity, it will be specified in the math, but if you need to know, it generally varies from 1 to 1.1 to 1.2. So in step number 4, there are 1, 2, 3 checks we need to do if the values are specified. So checks are there. Now coming to step number 5, calculation of the cement oblique cementitious material content. Cause number 5.4, calculation of the cement or cementitious material content. Now we know the water cement ratio, we have calculated the water content. Now we can calculate the cement content. So the cement content as per step number 3, we are water cement ratio, step number 3 we have determined. In step number 3 we have determined the water cement ratio. In step number 4, water content. So depending on the water cement ratio and the water content in step number 4, the cement content will be water cement ratio by the calculated water content by the calculated water cement ratio, because water by cement is the water cement ratio. So if we need to determine the cement, so it will be water cement ratio will come here and it will go here. So water by water cement ratio, cement content is calculated from here. Now coming to, here is a check. If then should be checked. Now in the table number 5 of IS 456, there is one term called minimum cement content that can be provided. So here we are calculating the cement content per meter cube. Here we are calculating water's content in per meter cube. Here we are calculating water content per meter cube of concrete. So here the cement content are also calculated per meter cube. So per meter cube, it should be always checked for the minimum cement content of table number 5. So the calculated cement content should be greater than the minimum cement content. The minimum cement content as per table number 5 of IS 456. This is the minimum cement content. Minimum cement content that can be provided. Okay, minimum cement content for PCC and minimum cement content for RCC that can be provided. Okay, so it should be greater than these values. Okay, depending on the exposure condition. Now coming to next check number 7. It is very important check I have specified here. Check number 7 states that if mineral admixture is used, mineral admixture like fly ash, gram granulated blast furnace slag, mineral admixture used. The mineral admixture that can be used generally are fly ash and GGBFS, which is called cementitious materials also. So in the cement content is termed, that cement content we have calculated here will be termed as cementitious material. That means cement. What is the meaning of cementitious material? Cementitious material means cement plus mineral admixture. Either it may be fly ash or it may be gram granulated blast furnace slag. Okay, so cementitious material, if it is specified in the math that we have to use cementitious material like fly ash or GGBFS, so instead of calculating the cement content, we will calculate the cementitious material content, because the cementitious material will be cement plus mineral admixture. So for this case, the cement content, now as we are using the cementitious material content, we have to increase the total cementitious material. Why? Cement is a binding material. Fly ash and GGBS have cementing property, but they are not as reactive as cement. Okay, fly ash and GGBFS also provide cementing property, but they are not as reactive as the cement. So as we are replacing the total cement with the help of fly ash or GGBFS, because cementitious material means cement plus fly ash or GGBFS. That means some portion of the cement will be replaced by fly ash or GGBFS. So for that, we have to increase the total amount of the cementitious material by a certain percent. Because what is the reason? I have told you that cementitious material, that is fly ash or GGBFS, are not as much reactive as cement. So the total volume of the cement total weight of the cement has to be increased as per the value specified here. It is said that the decision on increase in the cementitious material content and its percentage may be based on the experience and trials, or the cementitious material content so calculated may be increased by 10% for preliminary trial. So you have to increase the total cementitious material by 10%. So cement plus fly ash we have to increase by 10%. So for this case, the cement content oblique the cementitious material content calculated by the above formula will be increased by the 10% clause 5.4.1. So 10% we have to increase. So the total cementitious material will be this value plus 8 into 10% plus 8 into 10% will be the total cementitious material we need to provide. So as per the clause suggest. Now what is the amount of the GGBFS, what is the mass of the GGBFS and fly ash to be used? It is specified in IS 456 2000, again clause number 8.2.5.4. Let us go to IS 456. Okay. IS 456 says IS 456 says further advantage can be obtained by use of fly ash or gram granulated blast furnace slag. Okay, provided fly ash content is at least 20% and or slag content at least 50%. So I have been written here that fly ash to be used 20% by weight of the total cementitious material or more as per said here in IS 456, and cement GGBFS gram granulated slag 50% by weight of the total cementitious material or more that has to be used. Okay, so we need to increase the total cementitious material. If we are using fly ash or GGBFS, then we need to calculate how much fly ash and how much GGBFS to be used. If we can calculate the GGBFS and fly ash mass, then from the total cementitious material, if we can subtract this fly ash volume mass, then we can get the actual mass of the cement. So if, for example, you can see here, for example, if the water cement ratio is 0.43 that we have calculated here, the water cement ratio we have for 3, we are taking that value as our trial, consider a trial value 0.43, and water content calculated 197.16 that we have calculated here, 197.16. now for that we are calculating, and if GGBFS has been used, consider we are using gram granulated slag. Total cementitious material from this formula to be calculated, water content by water cement ratio 197.16 by 0.1 is coming to 458.51. Now first we have to increase, as we are using GGBFS, we have to increase the value by 10%. So increasing the value by 10%, then actual cementitious material 458.51 into 10%, that is 504.36. we are increasing the value. Now 504.36 is the total total cementitious material. Now we have to determine the amount of the GGBFS to be used. Now for GGBFS used is greater than 50 or more. So we are assuming 50% of the GGBFS we are using. So 50% of the GGBFS. So weight of the gram granulated blast furnace slag will be the weight of the total cementitious material into 50%, that is 252.18 kg. So we are getting the weight of the GGBFS, of the mass of the GGBFS to be 258.18. Then the weight of the cement only 252.18, because 504.6 minus that, it is, so this plus this is equals to 504.36. That's how we calculate the total cementitious material, that is the total cement plus total GGBFS content in the cement. So that check is very much important to apply this check. Now coming to check number 8, it is another important check. Maximum cement content to be checked as per IS 456 2000 8.2.4.2. If we go to 8.2.4.2 check here, it is said here, cement content not including fly ash and gram granulated blast furnace slag in excess of 450 kg per meter cube should not be used. That means the cement content only should be less than 450 kg per meter cube. If we are using only cement, so there is no need of gram granulated blast furnace slag, so we will use this cement content value. The cement content value, it should be less than 450 kg per meter cube. And if we are using GGBFS or fly ash, if we are using fly ash or GGBFS, so the total weight of the cement only without GGBFS. So in our example, what is the total weight of the cement only? It is 252.18. It should be always less than 450 kg per meter cube. So it is specified here. We are getting 252.18. So 450 is more than that, hence it is okay. So this is check has to be done also, the maximum cement content check. So here the cement content, total cement content is changing because we are increasing the cement content 10%. So finally the adjusted water cement ratio or the water cementitious material ratio to be calculated here. So the final water cement ratio to be calculated here, and it should be again check by table number 5, the minimum maximum water cement ratio. Okay, so this is the check number 8. Okay, now we are in the check number 8, how to determine the water cementitious material. So we have determined the cement content, we have determined the water content, we have determined the water cement ratio. The last thing that remains is the aggregate content. What is the amount of the aggregate to be used? What is the amount of the aggregate to be provided? Now, it will be as per step number 6, estimation of the course aggregate proportion. As per table estimation of the course aggregate, again coming to the 10262 2019 estimation of the course aggregate proportion. It says that approximate values for this aggregate volume for a water cement ratio 0.5. What does it say? The volume of the table number 5. Let us go to table number 5. Volume of the coarse aggregate per unit volume of the total aggregate for different zones of fine aggregate for water cement ratio or water cementitious material ratio 0.5. There are certain terms we need to discuss first. Volume of the coarse aggregate per unit volume of the total aggregate. That means if this is the volume of the total aggregate, by this table we are only finding the volume of the coarse aggregate Ca. So by this table we are determining the volume of the coarse aggregate only, the volume of the coarse aggregate only. So if we can determine the volume of the coarse aggregate, then we can subtract the value from the total volume and get the fine aggregate volume. So it depends on certain factor, depends on nominal maximum size of aggregate and water cement ratio 0.5 and different zones of aggregate. Different zones, there are 4 zones. You know that I have told you in the aggregate lecture in the class, that is there are 4 zones of fine aggregate. Zone 1, zone 2, zone 3, zone 4. So for each zone the value is different for various type of maximum size of aggregate. For 10 mm maximum size, for zone 1, zone 2, zone 3, zone 4 there are 4 values. For 20 mm there are 4 values. For 40 mm there are 4 values. So depending on the nominal maximum size, nominal maximum sizes and the zones, we need to take one value. For example, if we see a small example, if it is given zone of the aggregate is zone 2 and the maximum size of aggregate is 10 mm, so 10 mm and zone 2 it is 0.5. so volume of the coarse aggregate per unit volume of total aggregate is 0.50. so what will be the volume of the fine aggregate? That means the total volume of the aggregate unit volume, that means 1 meter cube is the unit volume. So for 1 meter cube the volume of the coarse aggregate is 0.5. so volume of the fine aggregate will be 1 minus 0.5, that is 0.5 meter cube. That's how we calculate the volume of the fine and volume of the coarse aggregate. Very important thing, we will discuss it later also. Here as an exception, we are determining the volume of the coarse aggregate, not the mass of the coarse aggregate. Okay, so in the latter stage we need to determine the mass also. So we are determining the volume of the coarse aggregate and the volume of the fine aggregate for 1 meter cube of total volume of coarse aggregate. Now comes check number 9, another important check. Now it is said here this value is only for 0.5 water cement ratio, but in our normal example, what value we have get? Water cement ratio value 0.43. so for that we have to change the aggregate cement ratio, aggregate per volume. So for water cement ratio, for other water cement ratio, rearrange the value. How? It is been specified, it is been said here. For other water cement ratio, for other water cement ratio, for proportion of the volume of the coarse aggregate for which may be suitably adjusted for other water cement ratio, the proportion of the volume of the coarse aggregate to that of the total aggregate is increased by 0.01 for every decrease in the water cement ratio. That means it has been said here, I have written it clearly that if the water cement or water cementitious material ratio decreases by 0.05, then increase the volume of the coarse aggregate by 1%. So if the water cement ratio is decreasing, we have to increase the volume of the coarse aggregate, and vice versa. That means if the water cement ratio of the coarse water cement ratio or the water cementitious material ratio increases, then by 0.05, then the decrease the volume of the water coarse aggregate by 1%. That means it is a reverse proportional ratio. Okay, disproportional ratio. That means if the water cement ratio is increasing, we have to decrease the volume of the coarse aggregate, and if the water cement ratio is decreasing, we have to increase the volume of the coarse aggregate. If we see one example again here, in the previous example, what the value we have got, that is 0.50 we have got. Now for 0.50, the water cement ratio that we have got is 0.39. Now water cement ratio we have calculated, it is the adjusted water cement ratio. Why? Because here the total aggregate total cement content has rises up to 504.36. so we will take this value from now on. So for 503.636 water cementitious material and 197.17 water content, the calculated water cement ratio is 0.39. What is the maximum? Or 0.45. It is less than 0.45. Okay, hence it is okay. Now the water cement ratio has decreased. What is the decrease in the water cement ratio? Decrease in the water cement ratio is 0.11. so if the water cement ratio decreases, then we have to increase the volume of the coarse aggregate. So if water cement ratio decreases by 0.05, then increase by 1% said here. So if decrease is 0.11, then readjust volume will be, as per the interpolation or Oikik Niyom in Bengali, it will be 1% by 0.05 into 0.01, that is 0.22. That value we have to, that value 0.22, that is the volume of the coarse aggregate to be used, extra volume of the coarse aggregate. So adjusted volume of the coarse aggregate will be 0.5 plus 0.022, 0.522 will be the adjusted volume of the coarse aggregate. Similarly, the volume of the coarse aggregate has changed. We are increasing the volume because if the water cement ratio decreases, here it is decreasing, so we have to increase. So the increasing volume is 0.522. so the volume of the fine aggregate will also change. Fine aggregate volume will change by 0.478. 1 minus 1 meter cube is the total volume. For meter cube we are calculating for unit volume, so 1 minus 0.522 we are getting 0.478. that is the volume of the fine aggregate. Now coming to the last check of this method, that is check number 10. Sometimes consider we need to make the concrete more workable. Why we need to make the concrete more workable? Sometimes consider we need to place a concrete in a position where there is a huge amount of reinforcement. Huge amount of reinforcing bars are there. So there may not be sufficient place to get vibrator inside. So vibration may not be possible here. So we need to create a concrete more workable, so it do not require the vibration. So for if the concrete is more workable, then the concreting is done by pumping, that is the hydraulic pump is used. In IS 10262, by here it is said that for more workable concrete, reduce the estimated coarse aggregate content, determine using table 5 up to 10%. I have written here, sometimes to ensure better workability, more workable concrete required. By the help of hydraulic pump system it is used. So as per clause 5.5.2, the volume of the coarse aggregate to be further reduced, the estimated by check 9. So we have here got 0.522. We will apply this check on that value. So reduce the estimated water content up to 10%. Okay, up to 10%. It will be, sorry, it will be 10%. Here it is also mistaken. It will be 10%. Okay, so another example, if we see, we in the previous example got the volume of the 0.522. We have got. Now if the concrete is pumpable, so concrete is pumpable, the reducing total volume by 10%. We are taking the value of 10%. So adjustable volume 0.522 minus, we have to decrease the volume. It has been said that we have to reduce. So that means 0.522 minus 0.522 into 10%, that is 0.4698 we are getting. So the adjusted volume of the fine aggregate will be 1 minus that value, it is 0.5302. We are getting these two values here, 0.4692 and 0.5302. These are the two values that we are getting here. So this is the most important thing, to determine the adjusted volume and adjusted volume of the fine aggregate and coarse aggregate. So up to this step we have calculated all the things. We have calculated the water, total weight of the water, weight of the cement, weight of the chemical mineral admixture, that is weight of fly ash or GGFS. We have calculated weight of the water, and finally we have also determined weight of the air content, volume of the air content in the previous step number 2, and now we have determined the step number 6, that is the volume of the coarse and fine aggregate. Now we need to calculate the mixed proportion. Coming to the calculation of the mixed proportion as per clause number 5.7, calculation of the mixed proportion. Okay, with the completion of this procedure, the ingredients have been estimated except the coarse and fine aggregate contain all the ingredients, because we have determined the coarse and fine aggregate by its volume. So these quantities are determined by finding out the absolute volume of the cementitious material, water and chemical admixture by dividing their mass by their respective specific gravity and multiplying by 1 by 1000. So we have calculated the weight of the cement, water, admixture, etc. So we need to change it to the volume. Okay, because the coarse and fine aggregate has been determined in volume. So volume of the cement as per the specified weight of the cement by specific gravity of the cement into 1 by 1000. We know the weight of the cement. Specific gravity of the cement will be given in the math. If we do not know, we have to take the value. Generally the specific gravity of the cement is 3.15 in general, it is taken here. Volume of the fly ash, also the same formula, weight of the fly ash and specific gravity of the fly ash and GGFS, the specific gravity will be given. With volume of the water, specific weight of the water, specific gravity of the water by 1 by 1000, specific gravity of the water is always 1. Volume of the chemical admixture. Now weight of the chemical admixture is the doses of the chemical admixture. We know the dose of the chemical admixture that we have discussed here. Dose of the chemical admixture is doses of the chemical admixture is 0.1 to 0.4 if plasticizer and 0.5 to 2.5 if super plasticizer. So total weight of the cement. So we will put the doses of the chemical, that is 0.5%, the X percent of cement weight. So the weight of the chemical admixture dosage, that is been the weight of the cement into the required amount of the doses, that will be put here. Specific gravity of the chemical admixture, it will be given also 1 by 1000. Now volume of the air entrapped, it is also we have calculated from here. We have in step number 2 we have determined the volume of the chemical air from here. Approximate air content we have determined for 1 meter cube of concrete. The air content we have determined, so we will put the value here. So we have calculated all the volumes that is A, B, C, D, E. So this is the total volume of the material. So in a concrete, if it is in a concrete, all the materials except the aggregate, the volume of the aggregate is there. So the total volume of the aggregate for 1 meter cube, total volume of the aggregate in 1 meter cube volume of concrete is 1, that is the total volume, minus these all volumes A, B, C, D, E, volume of cement, water, fly ash, GGBFS, chemical admixture, air content. So these are the other volumes. So if we all the values are divided from 1, we get the total volume of the aggregate. That means coarse plus fine. Total volume of aggregate, coarse plus fine is F. So this is the volume of the coarse aggregate for 1 meter cube of concrete. Then from this value we need to determine the weight of the coarse aggregate, weight of the coarse and fine aggregate. So mass of the coarse aggregate, that is equals to F, that is the weight, volume of the coarse aggregate into volume of the coarse aggregate calculated from here, that is that value and that value. We have calculated from here that value and that value, or that value and that value, that we have calculated values. So we will put the values of coarse aggregate and fine aggregate volume here. Specific gravity of the coarse and fine aggregate, it will be given and 1000. So we are determining this volume of the coarse aggregate is 1 meter cube, but total weight of the coarse aggregate and fine aggregate total volume is F. So we need to find out the weight of the coarse and fine aggregate per 1 meter cube. So this is the volume per 1 meter cube, and this is the volume of the actual total volume of coarse and fine aggregate. So in between 1 meter cube of concrete, what is the weight of the fine and coarse aggregate? We need to calculate by this formula. So putting all the values here, we will calculate the mass of the coarse and fine aggregate. This is the final step if step number 8 is not specified. So this is the last step. So after that we will write down all the mixed proportion of the materials if step number 8 is not specified. Step number 8 I have written if otherwise specified. If it is specified, we need to do. If it is not specified, we do not need to do. What is step number 8? Determination of or adjustment due to water absorption or free moisture of the coarse and fine aggregate. Now coarse and fine aggregate, if you take some amount of sand or stone, if we submerge it into the water, you can see the fine aggregate and the coarse aggregate absorb some amount of water. Also, if the sand or the coarse aggregate is wet, they will similarly give some amount of free moisture. So if the coarse aggregate or the fine aggregate have the water absorption or free property, or they have a property to give extra contribute free water due to their free moisture, then the total water content that we have determined from here and the total aggregate weight that we have determined from here will also be changed, because due to that the weight of the coarse and fine aggregate will also change. So we need to consider for that case also. Okay, so it is been said here that sometimes aggregate, coarse and fine have some water absorbing property. Also sometimes they, due to their inherent moisture, they give free moisture, I have told you, to the aggregate. For this reason the water content as well as the water cement ratio will also change. So we have to readjust the water cement ratio and water content as per the following procedure. Consider, so if the following procedure we have to follow if it is specified. Consider in the math it is specified that the water absorption of the coarse aggregate is X%, water absorption of the fine aggregate is X2%, X1% and X2%. Similarly, free moisture is Y1% and free moisture of the fine aggregate is Y2%. So if the coarse aggregate has water absorption as well as the free moisture property, so if X1 greater than Y1, that means if the water absorption value of coarse aggregate is higher than the free moisture, that means if consider a coarse aggregate is giving 10 gram of water but it absorbs 20 gram of water, so it is absorbing more. So that means X1 greater than Y1, then absorption greater than free moisture. So total water absorbed will be ZA is equal to X1 minus Y1. That means why it is X1 minus Y1? Because X1 is the absorbed and Y1 it will give. So total absorbed minus total give will be the actual absorbed if the X1 greater than Y1. Similarly, if X1 less than Y1, that means the total moisture contributed is greater than the total water absorbed. So the actual moisture absorbed will be the total moisture absorbed minus the actual total moisture contributed minus total moisture absorbed, that is ZB for Y1 minus X1. So for the coarse aggregate as well as fine aggregate, we need to check what value is higher, water absorption is higher or water contribution or the free moisture is higher. Similar for the fine aggregate also, we need to determine first these two steps we need to determine. Now coming to a theory. Now if the aggregate has absorbed the water, then the mass of the aggregate we have calculated is high as aggregate has absorbed some amount of water. That means consider this picture. Consider this picture. This is the aggregate. They have absorbed some amount of water. So this is the actual weight we have calculated. This is the actual weight of the aggregate. It should be, but as it has absorbed some amount of water, the aggregate plus water weight is now A plus B, aggregate plus water. So weight of the actual aggregate is A plus B minus, that is B. We are getting the actual aggregate, that is A plus B minus B, that is equals to A. We are getting the value. Now that B, that means the water content from the total mix, this aggregate has taken some amount of water, absorbed some amount of water, so we need to compensate the amount of water here. So the weight of the actual water will be calculated volume of the water that we have calculated weight of water plus that extra water that the aggregate has absorbed. You need to be clear about that thing. Okay, so weight of the actual aggregate weight will be the total aggregate plus water, the weight of the aggregate plus aggregate weight plus water weight minus the weight of the absorbed water. The weight of the absorbed water will be calculated from this value. ZB is the weight of the absorbed water. Then, and the water that is absorbed from the total mix, this is the deficiency in the water, so we have to compensate for the water. So the calculated value of the water that we have calculated value of the water plus the absorbed water. This is for the absorption case. Now coming to the contribution case. Now in case of the free moisture, aggregate has contributed some amount of water, aggregate has given some amount of water. So the actual weight of the aggregate will be weight of the aggregate plus weight of the water contributed, because consider we are taken this picture, consider this is the actual weight of the aggregate, but it has given free moisture, so the weight of the aggregate has reduced from the actual limit, but we have calculated the weight of the aggregate here some extra value, but due to this free moisture property, the weight of the aggregate has reduced, so we have to compensate for that. So actual weight of the aggregate will be A plus B, that means weight of the aggregate plus the free moisture it has been given, so that much weight has been reduced, so we may have to compensate for that much weight. So that much weight has to be summed, that much weight has to be added with that weight of the aggregate, that because that weight has been contributed as a water. Now coming to the actual weight of the water sorry, now coming to the actual weight of the water. Now when we are calculating the actual weight of the water here, so the aggregate has given some extra amount of water, so water is higher than the calculated value, so the water cement ratio will change. To keep the water cement ratio at that much limit, that much water given by the aggregate, this amount of free water given by the aggregate has to be subtracted from the calculated value of the water. So actual weight of the water will be calculated weight of the water minus B, because that much water, B value of the water has been given by the aggregate itself, so that much water has to be subtracted to keep the water cement ratio as per the required limit. So these are the theory behind the water absorption and water contribution. So consider, for example, if the water absorption, small example, if the water absorption of the coarse aggregate is 0.5% and water absorption of the fine aggregate is 1%, free moisture of the coarse aggregate 2% and free moisture of the fine aggregate is 5%. Now consider for coarse aggregate. For coarse aggregate, what is the water absorption? 0.5. What is the free moisture? 2. So what is greater? So y1 greater than x1 for coarse aggregate. So what formula will be determining ZB, total free moisture? So ZB will be equals to 2 minus 0.5, that is 1.5% total water contributed, total free moisture. Now coming to the fine aggregate, similarly fine aggregate, water absorption 1% and water contribution 5%. So as fine aggregate having here also y2 greater than x2, so ZB here is 5.1, that is 4%. So here the moisture content given, the contributed moisture content is higher. Okay, now the calculation of the actual mass of water and aggregate. Now adjusted mass of coarse and fine aggregate, calculated mass of fine aggregate or coarse aggregate divided by 1 plus ZA by 100 for coarse or fine, for water absorption only. It is this formula will be taken for water absorption only, not water contribution. Calculated mass of the coarse or fine, depending on coarse or it will be fine, 1 plus ZA. Why it is ZA? Because ZA will also only come when the water is absorbed. So ZA by 100 for CA or FA, that is the coarse or fine. Now this is the adjusted mass, actual mass. That means for this is the actual mass. Now if this is the actual mass, the water absorbed by the coarse or fine, so water absorbed will be calculated mass of the coarse or fine minus the adjusted coarse or fine. here A plus B minus B, calculated mass A plus B that we have calculated in the math, minus the amount of the water absorbed. So calculated mass of the coarse are fine minus the adjusted mass of the coarse and fine, that amount. So this will be the water absorbed proportion B value. So adjusted mass of the water will be the calculated mass of water plus the water absorbed by the coarse and fine. This is for the water absorption. Now coming for the free moisture. For free moisture, adjusted mass of the coarse and fine is a different formula. Calculated mass of the coarse fine into 1 plus ZB for coarse and fine. 1 plus ZB. Because why it is ZB? Because for free moisture value is ZB. That is the free moisture. So free moisture is that value. Water contribution by the coarse and fine will be equals to adjusted mass of the coarse and fine minus calculated mass. As we can see, this is the actual weight of the aggregate. So actual water contribution by the coarse aggregate will be A plus B, calculated weight of the water, A plus B, actual weight of the water, minus the adjusted mass of the water. That means it has some higher value, minus the calculated mass of the calculated mass of coarse and fine aggregate. That value we have calculated in the math. So if we subtract this value, we will get the amount of free moisture delivered, contributed to the concrete by the coarse or fine aggregate. Then that value has to be adjusted mass of water will be extra. So that water is extra in the concrete. So that value has to be subtracted from the actual water, so that to keep the water cement ratio at a required position. So the actual mass of the water, adjusted mass of the water will be calculated mass of the water minus the water contribution by that value. Okay, so by these formulas we can calculate the actual mass of coarse, fine and water. Now for example, if we see, for example, if weight of the fine aggregate calculated 500 gram, consider we have calculated gram, now it will be kg. Second change, it will be kg. Here it will also be kg, and it is kg, it will also be kg, and water is also 100 kg. Okay, so if weight of the fine aggregate calculated here, you have calculated here from this formula, mass of the coarse aggregate, fine aggregate calculated, it is 500 gram for coarse fine and 1001 kilo, that is 1000 kg for coarse, and water is 100 kg. And earlier we found that the total free moisture, coarse aggregate total free moisture we have calculated, that is for coarse aggregate total free moisture 1.5%, for fine aggregate total free moisture is 4%. So 1.5% and 4% is the total. So actual mass of the coarse aggregate will be equal to 1000 into 1 plus 1.5 by 100, that is 1015, because we need to follow here. So we will use the these formulas for free moisture. So formulas for the free moisture, if we use the formula for the free moisture, we will getting that actual mass of the coarse aggregate, adjusted mass, that is equals to calculated mass. 1000 is the calculated mass, we have calculated into 1 plus 1.5 by 100, because ZD is equal to ZB we have calculated here is 1.5% for coarse. So we are putting the value 1.5% for coarse and 4% for sand, and it is 500. So 1015 is the, and 520 is the actual mass of the coarse and adjusted mass of the coarse and fine aggregate. So the water contributed will be that value, adjusted mass minus calculated mass, adjusted mass this, and calculated mass is that. So 1015 minus 1000 and 520 minus 500, that is equals to 15 kg and 20 kg of the total water that is contributed. Now this water is extra, so from that actual water this value has to be subtracted as per the formula. So calculated mass of the water minus water contribution by Ishe, that will be equal to adjusted mass of the water 100 minus 15 minus 20, that is equal to 65 kg, will be equal to the total mass of the actual mass of the water. Okay, so we have calculated the actual mass of the water and coarse and fine aggregate by following that formula. This step is only applicable if the water absorption and contribution data are given. So up to that we have discussed till now how to mix design a concrete. At the final, what we have determined? We have determined the mass of the water. For 1 meter cube of concrete, we have determined the mass of the water, mass of the coarse aggregate, mass of the fine aggregate, mass of the chemical admixture, mass of the cement mineral admixture, mass of the coarse and fine aggregate adjustment by the water absorption or contribution, and mass of the water also by adjustment of the coarse and fine aggregate. So if we consider all this, we can get a mixed proportion. That means for a 1 meter cube of concrete, if all the conditions are provided, all the guidelines are followed of the IS code, what are the mixed proportion of the concrete? So for 1 meter cube, we are determining the mixed proportion, that is in the mixed design of concrete. So finally, we are determining the mixed design of concrete by this formula. This is all the steps we have covered, all the steps we have discussed, all the steps here. So for that, we need to concern about it. So this is the mixed design, the most important part of concrete technology. Please go through that, go through it very carefully, go through the steps, go through the checks very carefully, how the checks are applied. In my theory, in my material, I have shown you how the checks are applied. For small example, by giving small example, I have shown you how the checks are applied. So please go through that, please follow this, and then you can do the math. In an exam, 1 or 2 math will come from it, and if you follow all these formulas, all this code, 15 marks is sure to be get. Okay, so please follow the mixed design. It is not for only getting the marks. If you are in the site, if you are in a construction site, if you are in a high-rise building site, you as an engineer, it is your moral duty to design the concrete mix. You have to design the concrete mix. Okay, so clear idea, clear conception of concrete mix design has to be in your mind. So please go through that. It is the most important part of concrete mix design, concrete technology that I have told you till now. So please go through that, please study all the things, please see the video, and please remember to do all the steps very carefully. Okay, so for today, thank you. Next day we will try to do 1 or 2 example of the 1 or 2 example of mixed design. Then we will see how a mixed design of concrete is done. So today we have discussed the steps for mixed design. Okay, thank you very much. A message for you that you know that the coronavirus is spreading very fast, so please stay at home, please don't go out. Okay, you are a student, you have a very prospectus in your coming life, so please stay at home, stay healthy, stay safe. Okay, this is the message from my side. Okay, thank you for today. Okay.